Hi, so in this section, we are going to look at the evaluation models, the phase 3, which we talked about, where we are going to, continuously monitor the quality of our RAG system. So instead of simply generating answers, we want to measure how well the system is performing, right? So we track matrices such as faithfulness, retrieval quality, we'll see. Let's start from the top of the file. So what we are going to do, first of all, we are going to build a phase 3 folder, not inside it, phases. Yeah, we're going to build a phase 3 hard folder, and roughly we would need 3 files in this folder. So first of all, it's going to be evaluation.py. So import all the libraries that we would require, and these are like from future annotations. Okay, import JSON, then we have import OS, yeah, and then we'll have import time, and from data classes import data class, and then we have import numpy, pathlib, and then we are going to have import numpy as np. So next we are defining 3 configurations. Variable log file, okay, specifies where all evaluation records will be stored. So by default, logs are returned. Let me show you. OS on env, and we'll have eval log file, and by default log are written to data logs query log dot JSON. Okay, then next would be a baseline window, and it defines how recent queries we consider when calculating evaluation statistics. So the default value we are taking here, yeah, we'll take the default value as 50. Okay, then we have drift threshold. Okay, that defines acceptable performance drop before we raise an alert. So we will have same, let me just get the value right, threshold equals to int os dot get env, then we'll be like drift thresholds, and here we'll put a threshold value of 15%. Okay, now let's look at query matrices data class. So this data class represents a single evaluation record for one query. Okay, the question field stores the user's query, so it will have string. Okay, the answer field stores generated response, so that is also string as well. Then retrieve chunks, then it's integer. The retrieval score field stores average similarity score, that's going to be integer as well. Wait, go back and then fix it. And then we have faithfulness we'll write about, and okay, so it will be float, because it'd be a value between 0 and 1. Then latency, millisecond I want to, and then it would be how long the query took to process. Then the last would be cache hit, and then we'll have one more finally, timestamp, when the records when the query occurred. Think of query matrices as the schema for every row in the evaluation log. Now let's move into the logging section, and the first function is log query. The purpose of this function is to persist query matrices to disk. Okay, the first line ensures that the log directory exists. If it doesn't exist, Python creates it automatically. We'll see. Okay, query matrix is none. So here we will make it dot. No, it would be dot. Yeah. Make directory. If it doesn't exist, we are going to create one. Okay, automatically it happens in Python. Next, we open the log file in append mode. So now we'll open the log file as F, and then using append mode is important because we want to continuously add records without deleting previous one. So F dot write JSON dot dump. Okay. So then the matrix object is converted into a dictionary using asdict. And finally we will write the JSON string followed by a new line character. Okay, so as a result, every query becomes a separate JSON record inside a JSON file. Then we have next function as load logs. So what happens in this function is this function loads historical evaluation records. The parameter n allows us to load only the most recent records if desired. We'll check list dictionary. It will return us this. We first check whether the log file exists. If it does not exist, okay, if not, log file exists, so we'll return an empty list. Otherwise, we read with open log file and we read all lines from the file. So each line will be passed using JSON loads. F dot read lines. Yeah, now each line will be parsed and converted back into a Python dictionary. Lines if l dot strip. At this point, we have both storage and retrieval of evaluation data. So now records, and the next thing we'll move else in records. Yeah, it would be the function to score faithfulness. So which will compute a lightweight estimate of how grounded an answer is. In a production environment, we would typically use a framework such as RAGAS. However, this function provides us a fast heuristic that can run locally. So first thing, we'll pass answer as string and the parameter and retrieval score. Retrieve chunks, yes. However, and it will return us a float calculator. Okay, the first thing we will do is check whether an answer exists and whether any chunks were retrieved. So not answered or not retrieved chunks, return 0. Okay, next we create an empty set called chunk words, a set because automatically removes duplicate values. So we then iterate through chunks, okay, every retrieved chunk. So for each chunk we extract its text content. Yes, chatbot get text, and then we'll convert it into lowercase and split into individual words. My spelling is wrong here, please fix that. It's SPLIT. And then we'll go chunk words.update and we'll strip. Okay, only we'll just strip the contents for any extra marks. So we can build a vocabulary representing the retrieve context. For double and words. And then we are also, we will keep length of till 4. Yeah. The purpose of this is to build a vocabulary representing, the representation. So after processing all the chunks, the important terms that came from retrieval would only be retrieved. So next we split the generated answer into sentences. Short fragments are ignored, and if no meaningful sentences are found, length is strip. Yes, if not sentences, so we return a value of 0.05. Now comes the actual scoring process. That's we initialize a variable called grounded, and for every sentence in the answer we create a set of words. So for set in sentences, we will send words. Not split. Overlap. Sent. Word. And if at least 2 content words overlap, we consider that sentence grounded in the retrieve context. So that is what we are doing. And then if we will increment the grounded counter, so 2 grounded plus equals to 1. So this gives us, after evaluating all sentences, we divide grounded by the total number of sentences. So this would give us a value between 0 and 1. For example, if 4 out of 5 sentences appear grounded, the score becomes 0.8. And finally, we round the value to 3 decimal places. So now we move on to, matrix aggregation. So the function get matrix summary, calculates summary statistics. The parameter, I was trying to find something. The parameter n determines how many recent queries should be analyzed, same as above, and we first load the relevant records. So what we are going to do, if not records, we are going to create a list. And let me show you. We have the count. We are going to return the count type. Then we have faithfulness, retrieval score, latency, cache hit rate, and using NumPy we calculate everything. So then we move on. Then we also calculate everything. Then we have the summary function. All these values return in a dictionary. So then we calculate faithfulness. records, and then we are going to calculate same for average latency and then retrieval. So let me start with retrieve score. Then we're gonna have for list for latency, just change the latency faithfulness here, and then we are going to have cache hit values. So just change cache hit, and then we have cache hit. Now just pasting them, we'll calculate the average retrieval score. Okay, so we'll calculate average retrieval score for all of them. Return, and then we have the same. Okay, length of records and the same thing, faithfulness, retrieval score, latency, P95 latency, and cache hit rate. So P95 latency, it represents the latency below which 95% of requests fall. Okay, then this data class we are making for drift detection. And drift detection is important because system quality can degrade gradually without anyone noticing. So example document quality may change, so we are making a drift alert. Now what we are going to do, we define another data class, okay, with a metric field stores the affected metric. And then the baseline field stores historical performance, and the current field stores recent performance. So then the drop percentage field stores amount of degradation, and let me come here, it would be drop. I will fix that. And then we have sensitivity. So severity indicates whether the alert is warning critical or it's just normal warning. Now we'll move on to check drift function, which would actually tell us compare historical functions with recent performance. So alert. Okay, so if we don't have enough data, specifically fewer than 2 baseline windows, we return immediately. And we will just write for it. And if next we split the data in 2 groups. The first group represents the historical baseline, and the second group represents recent performance. This is us returning 0. Now we are splitting data into 2 groups. And then let's just split it, baseline window into 2, and then another would be the recent one. This is baseline window, and then an empty list we'll create recent reports. So alright, not seeing as baseline window. That's it. So 2 groups have been made, and then alerts equals to an empty list. So then we define which matrix should be monitored. Okay, currently we monitor faithfulness and retrieval score. So we'll have matrices to check. we'll have faithfulness, average faithfulness, retrieval score, and average retrieval score. Now we'll define a helper function called average. So this function will calculate the average value of a specific field across a set of records. This helper keep the code clean and avoid repetition. So then we can iterate through every monitored metric. So हम क्या करेंगे, सबसे पहले we'll calculate the baseline average field for RN records. The field and R return float. This is class L0.0. So if baseline is 0, we skip calculation to avoid division by 0. Next we compute the percentage drop. Let's pop it. Pass field. Okay. Now baseline. Okay, so if baseline value is equals to 0, we continue. Now we are going to compute the percentage drop. Right, this is what we talked about. The formula baseline would be minus current divided by baseline. If the drop exceeds the configured threshold, we generate an alert. And then for example, suppose baseline faithfulness is 0.9, okay, and the recent is 0.7, so the drop would be approximately 22%. So this would be determined, drop is more than twice, so it would be classified as critical. So what we are doing after all the matrices, we are also creating a drift alert object and we are appending it to the alert list. To summarize this, we have done 4 major tasks. First, it's like it records our detailed matrices. Second, it computes a lightweight faithfulness score. Third, it generates aggregate. And fourth, it continuously monitors the quality, system quality, so that it remains consistent over time. Return alerts. We are done with this file. Okay, so in this section we are going to discuss the RAGAS evaluation. So the purpose of the file would be to perform automated evaluation on a RAG pipeline. So this is where RAGAS come into picture. So RAGAS stand for Retrieval-Augmented Generation Assessment. Okay. Before that, I need to tell you all the requirements that we need for phase 3. These are all the requirements that you would need. Alright, and just go and type it, and the process. Pip install requirements are txt. Then we go back to the file, and so we became by importing from future import annotations, and then we have the JSON module. Okay, then we will have OS and we have async. Okay, this module helps manage event loops because RAGAS internally uses asynchronous. Then from path, import path, and then datetime is used for generating datetime. So next what we do is we define a report directory. Okay, so this specifies the directory where evaluation reports should be stored. So this is now function is the run RAGAS evaluation. So what it does, this function is the heart of the file. The job is to accept a test dataset, run RAGAS matrices, generate reports, and return summary scores. Okay, so the first parameter is test set, जो हमारा list है. Then we have report name. Okay, then it's optional, and if not provided, so automatically creates a timestamp. yeah, this will give us a dictionary, and then if there this just prevents unnecessary processing. Next we enter a try block. Not that set. Tone.
Hello.
Scores, and we have, now we come to the try block, and the reason is that it's like ragas depend on multiple factors. Okay, so any failure should not crash our website, so we should handle that well prepared. So that we have imported for our evaluation matrices. So is the main we import like faithfulness measures, whether the generated answer is supported by retrieve context or not. Then we have relevancy, we have context precision, we also have most relevant chunks, contents recall. So next we move on to the wrapper language models and embedding models. We also have like LangChain, and we are using Chat OpenAI and OpenAI embeddings. So they provide the actual language model and embedding model. Finally, we have import dataset sequence. So these classes help us structure evaluation data in format accepted by RAGAS. So when we like move on to the next section, that is particularly instruction, because we are importing RAGAS validation as our way. So what we are going to do there is that we are going to store the original validation function. That is, immediately after we create a patched version, this patched function simply does nothing. Okay, so why are we doing this? Some versions of RAGAS perform strict data type validation. In practice, our dataset structure is already correct, but RAGAS may still reject it due to schema mismatches. So by monkey patching the validation function, we bypass those unnecessary checks. This is essentially a compatibility fix. So yeah, this is what we talked about. Just ignore the terminal. It's the tool. Validate column data type. So this is what we are doing. We are just patching the validate column type. Then we are we are calling our LLM wrapper, which is chat OpenAI instance. We will use GPT-4o mini, and we tell the spelling is correct. So chat OpenAI, and we would be using model would be GPT-4o mini. You guys can upgrade if you want another like a more powerful model, but right now I'm using this one. And then I'm gonna have open API key is read from environment variable where it is stored. Okay, so this is important because we should never hard code API keys into a source code. Get env, and then we go open API key. Then we what we would do is just simply the embedding model is wrapped using LangChain embeddings wrapper. So now comes an important step. What we do, we iterate through every metric. For each metric we assign the language model. So you'll see 4 matrices that we would be passing here: faithfulness, relevancy, precision, and recall. Just a second. Yeah, we'd be using the model text embedding 3 small as been told previously, and our open API key is again same, gonna be at the env file, just copy from the above. Okay, then missing one opening closing bracket, so just give me one. Maybe move on. Now we are iterating through every metric from metric. Yes, this is what I was talking about. We would have faithfulness, answer relevancy, and context precision, everything here. And these are the features that we are taking: question, answer, context, and ground truth. Okay, so everything question is string, answer is string, context is string, and ground truth we are also storing it as a string. This schema guarantees consistency across all evaluation examples. Now so we explicitly ensure context are stored as list. So moving on, we go to the entry point of no, we are into, now we are storing the data set, the resulting data set, into a Hugging Face data set. So that this avoids dataset formatting issues later. So at this point, our evaluation data is fully prepared. The next section deals with async here. RAGAS internally uses asynchronous execution. Okay, sometimes environments such as notebook or web applications already have event loop running. So this can cause runtime errors. To prevent this, we check whether an event loop exists or not. So if the current loop is closed or unavailable, we create one. Let me go into right there. So we start building it, and then we are doing a loop. So if the loop is closed, raise runtime error. Except runtime. Loop plus async. Your event loop, creating one. Compatibility across different execution environments. So loop, okay, finally scores. Now we run the evaluate function, and the evaluate function receives two things, that is dataset 1 and second is matrices. Okay, so RAGAS processes every evaluation example and computes scores for each metric. Yeah, these are the 4 matrices that we pass, and after evaluation finishes, we restore the original validation function. So this is a good practice because it prevents side effects elsewhere in the application. Next, we will create the evaluation report dictionary if it doesn't already exist. And that is what we are going to do. P on just exists, okay, equals to true, and then we'll move on. Just so what we are going to do now is that I mixed it up. This original validate, then we'll start with another one here. So this is the dictionary that we have to make, and then what this does is like this guarantees unique file names. So what happens is that next we create the evaluation report dictionary. Okay, then we generate the report name. If the user supplied a custom report name, we use it. Otherwise, we generate one using the current timestamp. So this guarantees unique file names. The data frame is then saved to as a CSV file, and then the CSV file contains detailed metric scores, and then for each matrix we calculate faithfulness, answer relevancy, contest precision, and context recall. So we also record the number of evaluate questions, and finally we store the path into CSV. Then we are just raising an exception error. Okay, so instead of returning a vague error message, we return the full stack trace. So what we are going to do, if an exception occurs during execution, we move into the except block. Okay, we import traceback, so this makes debugging significantly easier. So as you can see, and we have traceback dot format execution, and then we get score. Empty. Now we move on to the next function that will be will test set from pipeline. So what it does, it will automatically generate evaluation data sets from the actual RAG pipeline. So this function will accept a list of question and ground truth pairs. Let me just write it. Okay. It will also accept top k parameters. So top k determines how many chunks should be retrieved. Console top k parameters, that is integer, and then so we are taking as 5, and it would return us a list. Inside we would have tuples, just a dict. We just have a dictionary. So what we are doing here is we are creating an empty test set list. So for each question we run the actual RAG pipeline, the generated answer is collected. So the original ground truth answer is also preserved. Everything is packaged into a structured evaluation. So this function is extremely useful. because it allows us to automatically build evaluation data sets from real pipeline outputs. So while I'll display you how finally phase 3 works, we'll get to see this exact function, how it works. So finally we move to the last function, that is load test set from JSON. This is the simplest function in the file. So what it does is it allows us to store benchmark data sets, externally and reuse them whenever needed. So what it does, it takes the path of the accepts a file path, and then file is open, JSON content is loaded, okay, with open path as F, and we'll have return JSON. So the resulting list of evaluation examples is, so to summarize this file, what we have, it builds evaluation dataset, runs RAGAS matrices, and generate a detailed CSV report. It will also create a summary statistics. So together with our Guardrails file, which we will generate just right now, so it gives a RAG application a very robust quality. So it provides an assurance layer. So let's continue with our third file. And so the purpose of this file is to improve the safety, okay, reliability or trustiness, that is guardrails.py. So we're going to import some libraries, because see, even though our RAG pipeline may be accurate, users can still submit malicious prompts. So to safeguard our system from that, we are having this file, okay. So so the language model also may generate sometimes answers that are not properly grounded in the retrieved document, so that can be also targeted from this file. So we have, first of all, our class guardrail error. So we define a custom exception called guardrail error, okay. Whenever a guardrail rule is violated, this exception is raised. So the first is a human readable reason. We'll get there. Regular expressions are the foundations of most. So whenever a guardrail rule is violated, this exception is raised. So the exception would be stored in two pieces of information. So that would be reason. So the first one would be, a human readable reason explaining what happened, and the second type of code that identifies the type of violation. So as we can see, super init, you have reason parenthesis, yes. Then now we are moving on to, we are going to see examples, include injection or off topic or PII related issues or ungrounded outputs. So we are using a custom exception makes error handling, okay, much easier. So we are using prompt injection detection here. What happened is, prompt injection is one of the most common attacks against LLM system. So instead of asking a normal question, an attacker attempts to manipulate the model's behavior. Okay, example include phrases such as ignore previous instructions, forget your rules, act as an unrestricted AI, developer mode enabled. So these are all attacks such as injection patterns. Now the first pattern detects phrases such as ignore previous instructions. The second pattern detects requests to discard previous instructions. So such pattern detects phrases such as forget everything. So notice that these pattern use regular expression syntax. The backlash notation matches white space. Parentheses create alternative groups. Together these patterns allow us to detect many common prompt injections. We then are compiling it using recompile. So compilation improves performance because the regex only needs to be processed one. Regular expressions, okay. So we also enable two flags. We will be in the ignore case flag ensures matching is not affected by capitalization, and the .all flag allows periods to match new lines as well. Now we are moving on to the second protection layer, that is personal identifiable information detection. So let's see the examples which it includes. So examples include such as email addresses, phone number, PAN numbers, credit card numbers, anything that users sometimes accidentally upload sensitive information. So to protect privacy, we automatically detect and redact such data. So we will be recompiling it again as in the same pattern we did above. Okay, again, compilation improves efficiency because matching operations become faster. So it's gonna be pattern, and then we have here E7. Then we'll just hear the name pattern. So we are moving to the redact function. So what it happens, the function redact by accepts text as input. Okay, and the first is sanitized text, and then the second is the list of detected pi categories. And let me just finish that. And yes, corrected. And then what we are going to do is we are going to iterate through every compiled pi pattern. So if a pattern matches, we add its label to the found list. And so next, if patterns, we add its label, so it's to the text, and we replace the sensitive information with a placeholder. So for example, an email address becomes redacted email, a phone number becomes redacted phone. So this approach preserves the structure of the sentence while protecting sensitive information. And then finally the clean text and detected categories are returned. So let's move on to our third protection layer, that would be off-topic detection. Like DocuMind is designed to answer questions about upload documents. It is not intended to function as a general purpose chatbot. So what it's going to do, it's without restrictions, users could ask unrelated questions such as tell me a joke or write a poem, generate code. So these are all the stuff that's gonna restrict that. So we again combine these patterns into a compiled regular expression, and then let's move recompiling it. Okay, it's the same process. And ignore case. Now we'll move on to the first function, that is check input. So what this function does, it acts as the entry point for validating user questions. So whenever user submits a query, if it should pass through this function before reaching retrieval or generation. So the first check ensures the question is not empty. So if if a user submits a blank query, we immediately raise a guardrail error. Raise guardrail error. Next, we would be performing a prompt injection detection. So the compiled injection reject searches the question. Okay. If a match is found, we raise a guardrail error. The error explains that the query resembles a prompt injection, and the result is blocked before reaching the language model. So, this is how we prevent malicious instructions from influencing generation. Then we move on to the off-topic search questions. So it's same, raise guardrails errors. We can write such lines here that you can customize according to your choices. And then we finally, after the pie off topic, the clean question is returned to the pipeline. At this point, the input validation stage is complete. Let's move to output validation. Okay. Return clean question. And now we move on to the function that is check output. Okay, so what check output validates is answer generated by the language model. So the first check ensures the answer is not empty. That is what we are going to do. Before that, let me tell you, in your env file, you have to go and you have to add these two texts, that is guardrails enabled equals to 3 and cache similarity threshold equals to 0.92. I hope that is clear. And now going back to our file, we will talk about output, string retrieved, and so the model returns an empty response. Again, a guardrail error is raised, would be raised. If not answer or not answer found, raise guardrail exception. Next, we will be working empty answer. You can write whatever clause you want to show from there. Okay, next we are going to define a list of refusal phrases. And they'll be like could not find information, not mentioned in the document, or such that these phrases indicate that the model is honestly admitting that the answer could not be found. Okay, the interesting part is that, which will come next, is we want to determine whether the answer is grounded in retrieved content. Okay, if the retrieved chunks exist, we extract the document names. For example, a retrieved chunk may come from annual report.pdf. We then check whether the generated answer references at least one source document. So the answer is considered grounded if it contains a document name. Alternatively, we also accept answers containing source citations such as source references or page references. So if no evidence of grounding is found, we do not completely block the answer. Instead, we append a warning. Okay. We append a warning message. So, and then finally, warning informs us that the user, that the answer may not be fully grounded in the source document. This is known as soft guardrail. So rather than preventing the answer entirely, we provide transparency about its reliability. And finally, we will validate answer, as a result. So to summarize, this file serves, security and reliability layer of the RAG system. And before generation, it blocks prompt injection, and after generation, it verifies whether answer appear grounded in retrieved documents or not. So together, these guardrails improve safety and privacy, and also the trust factor of the project that you are building. And this is done. This file is completed. So in this section, as we have finished our guardrails.py, so let's move on to our core part where our pipeline.py needs to be changed. Okay, so let's go there. And so what we are going to do here is, the purpose of the update is to transform our basic retrieval augmented generation flow into a more production ready system, right? Because earlier what we are doing, we didn't have earlier what we had was the pipeline accepted a question, okay, generated an embedding and retrieved relevant chunks. But what we are doing now is it lacked several compatibilities, okay, important compatibilities, like what if there is a malicious user input and there is no mechanism to measure the quality of answer over time. So this is what we are going to achieve from here. And we need to make a couple of changes in pipeline.py. So first of all, the very first things we are going to do, as I've already said that we have used guardrails here, semantic caching is there, and evaluation of observability. So let's just implement them here, what we have already done. So let's start. So first of all, what we are going to do is we are going to have a helper function, okay, called let me make it here, just go back, and it would be, no, this we have done, pipeline.py. So the helper function, what we will implement here will give us, help us whether to determine all the phase 3 modules are installed and available or not. So phase 3 available, we are doing bool, we'll set it to bool, and try, we will see from phases 3 hard dot guardrails import user check user input, okay, and then we are saying return true and accept exception, import error, return false. So this was just our helper function, okay. So then we move on to lower section. Our ingest document is going to stay as same because we didn't change any function related to this. And then what we are going to move into is next our query document function, which will come here. It's all gonna stay same. Now this is phase 2 part, it's gonna stay same as it is. Finally we are in a query document, okay. This is the portion, this is the part where we're going to make changes. So first of all, what we are going to do is yes, here we are, okay, we are initializing a variable called cache it and we are setting it to false. And second thing what we are going to do, just for we need to record the current timestamp. So we are making a timestamp that will be later used to calculate latency. Next we move on to major phase 3 enhancement, okay. So what we are doing here is to check input, okay. So this function input checkbot and guardrails errors fix here, yes, try, and we have question equals to check input and we are passing the parameter question. Yes, and then we'll have answer. Yes. So if stream, we are returning, we would be returning blocked. Okay. Yield. It would be blocked and error reason. Dot reason. Wait, let me fix the annotation color. Yes, colon and then tab. Right. So what it is doing, if a streaming module is present, we will create a small generator function, so it will block the message, right? This will allow the UI to continuously, continue using the same streaming without any modification. If our streaming function is disabled, so we just return a query result. Okay, so it's a query result object, so it will just contain the error message. In both cases, the query never reaches retrieval or generation. That is the point for this. Sources equals to sources. No, it's an empty list, and then query equals to question, and top key equals to top key, right? And only after a question successfully passes all guardrail checks, we move on to continue to the retrieval process. So this will remain, and then we will this is same, and now we will talk about semantic caching. Answer this. So what we are talking about here in this function, so what we are saying, semantic caching and phase 3 available both. So up just performing a retrieval, we also check if the query has similar semantically and has been answered already. So what it does, traditional caching only works when two strings are exactly identical, but what semantic caching does is it's way more powerful because it compares meaning rather than exact wording. So for example, two users may ask the same question using different phrasing, but if a similar answer already exists in the cache, the pipeline can immediately return it. So this was a major part of our phase 3, which we are implementing right here. So it also reduces vector database queries and LLM API costs, right? So it is beneficial both on efficiency, resources, and time management. So if no cache entry exists, the pipeline proceeds normally. The next step is retrieval. Okay. Again, it has the same if stream, we call so the stream, yes, goes to the cache hit. Generation is so yield, we have cache answer, and then we have yield. Oh, table is updated cache hit. And then we will talk about similarity here, similarity score, right? So, when a cache hit occurs, so the variable is updated to true, all right? And then we are also telling what is the similarity score of the return answer, okay? And then cache generation, and if not cache, if does not, so the pipeline proceeds normally, okay? And yeah, answer equals to cached answer. Sources, and then wait, let me fix that. It goes here. Need control C and it will come right after answer. This and then query equals to question. Top K equals to top K. Cache equals to true and latency ms equals to latency ms. That's alternate, and then we move on if, and we have our except. Okay, we will just throw an exception and it will say pass. Okay, so it will just move on as normally. So this is what we are talking about. Then this is the area what we were talking about. So the next stage is retrieval. What it happens that query embeddings is sent to vector database, and then vector database performs a similarity search which returns the top K matching chunks. So what happens that retrieved chunks becomes the context applies to the language model, and that quality directly influences the quality. Okay, so once retrieval is completed, the pipeline moves into answer generation, and the question and retrieved chunks are provided to language model. So using this context, the model generates a grounded answer. Now at this point, the system has produced an answer, but we still need to validate. So this brings us to the second guardrail layer, and this is the portion that would be changed here for streaming. Let me just show it to you. Just a second. So in this section, what we are doing, whatever, if streaming is enabled, we wrap it into a LLM response, okay, inside a custom generator. And if as tokens were used, immediately हमारा answer is streamed. ठीक है? Once generation finishes, the answer passes to the output guardrail to check whether it is properly generated or not. Okay, next the final answer is stored in the semantic cache, so future similar question can be answered faster, right? And if the non-streaming path, the same steps occur: guarded validation, semantic caching, latency and ms calculation. Okay, but the complete answer is processed at once instead of token by token. That is the difference between streaming and at once. And at last we have query result object that contains the answer, sources, query details, and cache status and latency information of the return. So this is what is done in this section. Okay, let's move on to other part. So now what we are going to do is we have evals now. Just and if phases 3 available, try it. Yes. Yes, here we are checking for the output. Check output guardrails, and answer equals to check output answer. It's same as what we did above for checking input, and this is what we are doing now for check output. We are validating it with the our citations. We accept exception and we have pass. Okay, so just start in time zone, and then we have checked our we are validating our answers. If not, Yeah, this is what I told you about, that semantic cache. It would be storing every embedding question and answer, except again we will be like exception, and it will be pause and latency I must equals to time. So success. So false, yes, and return query result. Okay, query matrices, and we would have our answer equals to answers, and our sources equals to sources, and then query equals to question, top k equals to top k, and cache equals to false, and latency ms equals to ms. Now, when we are done, so we can finally move into the evaluation part. Okay, and wait, let me see. So what we do here is that we are calculating the very first thing, that is latency. So what we are doing is just subtracting the timestamp from the current timestamp. Okay, and it's converting it into milliseconds. So this tells us exactly how long the query required to execute. And then these are all the matrices that we are calculating. That is, we are calculating retrieval score, that is retrieval, with the help of retrieve chunks. Then we are also calculating faithfulness, we are calculating latency ms, then calculation it, and that's the timestamp. Okay, so higher retrieval scores generally indicate that more relevant context was found, and after that we calculate faithfulness. Okay, and faithfulness measures how well the generated answer aligns with retrieved context. So although this heuristic is simpler than full RAGAS evaluation, it provides lightweight real-time monitoring. Then after all these objects, values are stored inside a query matrix object. Okay, then a query matrix data class is formed, and that just captures the original question, answer, retrieval score, and all the things that we covered here. And once the object is created, we call the log query function, and this just write matrices to a JSON file, log file, and then these logs become the foundation for observability and drift detection that we will be doing in the phase 4 section. So over time we can monitor whether faithfulness decreases or retrieval quality changes or latency increases. So this is almost done, and at the end we can just have another function check, that is if def phase 3 available bool, and return phase 3 available function. So to summarize, phase 3 has ended, and it has significantly improved the robustness of DocuMind pipeline, okay, which we talked about guardrails and semantic caching. So let's move on to the other part. All right. Okay, so last but not the least, let's make our initializer package inside phase 3. So what it would do, it would turn our phase 3 hard folder into a Python package, and it will provide a single entry point for all the functions. Take it, instead of us individually importing functions throughout the code base, we can just import them directly from phase 3 hard. So this is how we can obtain it. So these are all just the functions that we made throughout the file in guardrails, and then cache, and then evaluation, and then RAGAS eval. So that is all. Then now I can finally run it and show you how it looks like. Okay, so before we start our phase 3 terminal UI, small changes in app.py, let me tell you, this is our env plus phase test action. This is the previous work only. Now we have added phase 3 guardrails plus cache eval. Okay, if it works, then the ask tab is same. Okay, then we are integrating here guardrails, so it shows that here is cache. Okay, and then sources about that same, job queue is as it is. Okay, no changes here. Eval and matrices, this new tab is added for our new phase. Okay, you see it in the UI right now. And then RAGAS evaluation, run RAGAS, core faithfulness, relevancy, these are all the matrices that we will be showing there. And documents, it was as it is, so not much changes, only like 2 tabs have been changed, and this code will be provided, do not worry. Okay, so before we start, there is just one thing that I forgot earlier. It's just in pipeline.py. Before the streaming part, just need to add this little function. So what we are going to do for keeping our verification for guardrails. Okay, so we are calculating a score. So if our score would be below some threshold, it would return us this question doesn't appear to relate to your uploaded documents. DocuMind only answer questions about them. Okay, so this is just calculating the latency, and if stream and yield of topic, and it will give us the reason. Right now we are done. Okay, so guys, there's a small blunder here that I noticed, that phases 3 hard is outside phases, so it would be a path problem, although in the code we have taken from root directory only. So let's move phase 3 hard to phases, and yes, now phase 3 is inside phase 3 hard. No, what did I do? Wait, let me fix this. This was wrong. Control S, and then another thing to add here is that we haven't added cache hit equals to bool, and this would be false. And the next one is latency. MS would be root equals to go. And a little changes here so that our system does not break. So what we can do is we can define reason equals to e dot reason right here only, and we can remove e dot from here. Okay, so these were the couple of changes that needed to be made before we run the system. And please make sure that you run the Celery and Redis, Celery worker and Redis server as well, otherwise it will not load. And then there was another one minor changes, that was the spelling for 249 here. So if I made a mistake of writing e here, so when it's fixed, so that this function can be loaded, that is for matrices. That's it. So what do we do here is Streamlit run UI app dot UI. Okay, so here we upload our files, and then I found computing, and then we ingest document. We'll just track it in the job queue and refresh, and you can see uploading to vector store. Again refresh, and it's success. And we can see that we have 81 chunks, 23 pages, and approx 32.5k tokens. So this was our matrix for the PDF. And let's ask a question. Okay, let's ask, what is the weather today? And let's see what answer does it give it to us. Okay, as yes, exactly, it says off topic, this question doesn't appear to relate to your uploaded document. So Guardrail is working spot on. This is what it was supposed to do. And as you can see below, cache is 0 hits and 19%, and hit rate is this much. These are all the relevant data that it's telling. Okay, so now let's try to ask some relevant question. As this is a PDF based on fog computing, let me just ask what is fog computing. And okay, and it would give us, okay, so as I had already asked this question before, okay, fog computing is a highly virtualized platform and that provides compute, storage, and networking services. So what happened is that it gave me the answer instantly, and it shows clearly a cache hit similarity 0.9814%. all right, so this is the caching part of our phase 3. Right before it we saw the guardrails, and now let's move on to the eval part. That was the evaluation part. So what eval does and what RAGAS evaluation does, let me show you. So first of all, what we are going to do, we are going to make a test set. Our test set should look like this. Okay, I have a file name known as testset.jsn in my system, and what we are going to do is whichever PDF that you guys are using for this system, you can just have 3-4 questions and in a format this way, question, and you have your respected question. Like I had what is fog computing, and then I would have ground truth, and I would write stuff about it, and then at the end then I'll have another question, another ground truth, another question, another ground truth. And you need to save this file, okay, so that we can compare and evaluate how well our system is working. So what I will do, I have already created that file, so I'm just gonna upload that file, and it's from the name testset.jsn. and no wait, I have to all files, and let's go. Okay, and then I'm gonna upload it, and then we are going to run our RAGAS evaluation. All right, it says 14 pair loaded. I just made 14 pairs because it was a fairly big PDF, but you guys can have 4 to 5 pairs. Let's just wait. And no drift detected. This block means that our system has not degraded since the last time. Okay, and above it's just some metadata about this, what we have done till now: latency, retrieval, queries, faithfulness, and cache it. As we can see, if faithfulness is quite low, we can work on that. This is the exact purpose of having evaluation and matrix, so that you can examine how well your system is performing. Okay, a little bit more time for the run. Okay, so as we can see that our evaluation has been completed, so we can see faithfulness 0.702, relevancy 0.829, precision is 0.929, and recall is 0.64. So it is indicating that our RAG is performing really well. So, and as you can see here, no drift detected. That means that our system has not degraded, and therefore this is the whole evaluation for now. Now this phase 3 is completed, and we can head to phase 4.